This is video 6.1D in trigonometry, inverse circular functions. So this is where it gets fun. Example 5, evaluate each expression without using a calculator. Isn't that crazy that you can take something as wild as this and be able to solve that without using a calculator? That is just crazy. Alright, so we're going to take this and we're going to rewrite that, because it's in the parentheses, as tangent of theta equals 3/2. Alright, so there's some angle that when I take the tangent of it, I get 3/2. So that's what I'm going to do first, and then I'm going to take the sine of that answer. Alright, so I'm going to draw little xy axis. I always do this. I draw these little xy axes just to make my life easier, and it's 3/2. So it can either be in quadrant 1 or in quadrant 3 because they're both positive. So the inverse tangent function, though, can only be in quadrants 1 and 4. If you look at the top of 242, it says 1 and 4 are your only options. Well, this says it can be 1 and 3. Well, if 1 and 4 are my only options, it's got to be in quadrant 1. So I've got an angle here with my opposite being 3 and my adjacent being 2. And then I use Pythagorean to find that my hypotenuse is that. So if my tangent of theta is 3/2, then my triangle looks like that. Alright, so if I want my sine, then I'm going to take the sine. So this right here is that. So when I look at that triangle there, I know my sine is going to be opposite over hypotenuse. So it's going to be 3 over, well, let me rewrite this. My sine of theta, whatever angle that is going to be 3 over the square root of 13, or doing my work here so that I get rid of my denominator there, that's what I get for the sine of this. So I did that without a calculator, just by making that drawing. These drawings are very, very important to be able to do. You need to make sure that you use those. So let's look at B of example 5, where we have the tangent times the cosine, -1 of -5 over 13. Okay, and because you're so smart, you realize that this negative is on the 5, not the 13th, because adjacent over hypotenuse. The hypotenuse is always positive, so therefore this negative value needs to be on the 5 for the adjacent. So that means that I have an option, according to my book, that I can be in quadrants 1 or 2. Well, I know in quadrant 1 cosine is positive, and I know in quadrant 2 that cosine is negative. So that means that I'm in quadrant 2 here. So I can draw my handy-dandy little chart here, or picture, and I just do that. Doesn't really matter if it's accurate or not. You just want to make sure that you get your stuff in here right. And so I have a -5, 13, use Pythagorean, I find out that that's a 12. Alright, so what I'm interested in is the tangent. The tangent of this, because all I'm doing is looking at this triangle here, the tangent of theta then will be opposite over adjacent, which will be 12 over 5, and my 5 is negative. So that ends up being my answer for that problem. So let's look at example 6. Evaluate each expression again without using a calculator. Cosine of arctangent square root of 3 plus the arcsine of 1/3. Alright, so what we've got here is we've got two completely different triangles we're trying. So let's draw it twice. So let's draw the arctan of the square root of 3 and the arctan of 1/2. So let's see. If the arctan of square root of 3, then we have the tangent of some angle, let's call it A, is the square root of 3. And we have the sine, let's call this one B, is 1/3. Alright, so let's go ahead and draw these. Tangent will be in quadrant 1, and that is opposite over adjacent. So that tells me my adjacent is 1. This is the square root of 3. Using Pythagorean, I find that to be 2. And my other one is also in quadrant 1. And I know opposite and hypotenuse, which means this is 2 square root of 2. Alright, so got the hard part out of the way. Now if you remember from section 5.3, whenever we add, and again, so this is actually cosine of A plus B. Because we got A here and B there. Okay, when that's the case, that is the cosine of A, cosine of B, minus sine of A, sine of B. Alright, so I'm just going to put those numbers in their places there and see what we get here. So we've got cosine of A, which means that this is my A right here, so I'm going to look at that. Cosine of A is going to be 1/2 adjacent over hypotenuse times cosine of B, so I'm looking at the cosine of this one, which is going to be 2 square root of 2 over 3 hypotenuse minus the sine of A, square root of 3 over 2 times the sine of B, which is 1/3. So I'm going to just do the math there, and I get 2 square root of 2 over 6 minus square root of 3 over 6. I can bring those together and get 2 square root of 2 minus square root of 3 all over 6, and I'm done. So let's draw that here. We're in quadrant 1. Sine is opposite, 2 over 5. This one's going to be the square root of 21, using Pythagorean to find that. And we're going to say that this is our B. We're going to set that equal to B, because that's an angle that has as its ratio 2/5. So that's an angle. So I'm going to rewrite this then as tangent of 2B. 2 times whatever angle that is. And remember, we have a double angle identity that looks like this. This is from section 5.5. Okay. So, since the arc sine of 2/5 is B, then the sine of B equals 2/5. So, the sine of some angle is 2/5. Okay, we are in quadrant 1, and we found all 3 of our sides, and we know that the tangent of B is going to be opposite 2 over adjacent. So now, whenever we see the tangent of B, we're going to put 2 over the square root of 21 in its place. So I'm going to erase this stuff here, and we're going to put 2 over the square root of 21 in the place of the sine of B. So that equals 2, this 2 right here, 2 over the square root of 21 over 1 minus 2 over the square root of 21 squared, and that will equal 4 over the square root of 21 over 1 minus 4 over 21. Find common denominators there, bring those together, and you end up getting 17 over the square root of 21. Or just 17 over 21, sorry. And we get rid of that, so we multiply top and bottom by the square root of 21. And we end up with, on the top, 4 square root of 21 over 21. We invert and multiply. Those cancel. Oops, that's not a 21. Dyslexic. Alright, so we end up with 4 square root of 21 over, 17. I don't know where I get a 21 there. So we get 4 square root of 21 over 17 for the tangent of that. And that will be it for lesson 6.1.